Okay. Okay, it is 1:30. I'm just going to type a little note in here. Okay. I'm not sure if that's going to come through. The class is going to start a little later today, right? So it's going to be because I had a lot of problems getting a feed. It took me half an hour to get onto YouTube. So I hope that's just an anomaly and that's not going to happen every day. As I said in the blog, if you were looking at the blog before class started, my goal was to kind of take a look at a couple of these in assignment 4, go over the homework and start lesson 5. You will need your graphing calculator app or program, so make sure you have that open. So assignment 4 says identify characteristics of linear functions from an equation. We learned yesterday that a linear equation, I'm going to say general form of a linear equation or function. Function means when it's actually put on the graph, and an equation is just something in y equals form, right? So this is the general form, y equals ax plus b. Okay, so it's a polynomial. See, it's a polynomial, and it has a y. It's in y equals form, and that becomes very important. It's got an x and a y in it, but it also has an a and a b, and these are numbers. The x and the y stay as variables. These are numbers. This is called the leading coefficient. And if it's positive, okay, if positive, the graph slopes up, right? It trends upward. The line is upward. If negative, the graph slopes down a horizontal line across the page. All right. So this also has some significance too. We're going to see this b value. This is the y-intercept. I don't know if you noticed that yesterday. Some of you eagle eyes may have spotted that. Whoops, intercept. We're going to talk more about that later. Okay, but we were kind of focusing on what the lead coefficient was and deciding if the graph was an up or a down graph, right? So another thing you could do, you have your graphing calculator. So what I'm hoping you do is you kind of just look at this equation and just even looking at the equation itself, kind of trying to determine. So if I look at this equation, I look at the equation and I can tell a lot about the line already. The leading coefficient is positive, right? Positive. Therefore, the slope direction is, it slopes up, right? It rises to the right. Meaning, as we move across the page from left to right, it rises. End behavior, we learned yesterday, if you remember, if you were back at yesterday's assignment, all the positive, anytime I had a positive, kind of circle the 2 positive lines we had. We only had 2 positive lines. They always rise to the right, and they always go from quadrant 3 to quadrant 1, right? They were matching. Quadrant 3, quadrant 1. So when you establish you've got a positive lead coefficient, rise to the right, it's always going to be quadrant 3 to quadrant 1. Rise to the right, or rises to the right, end behavior quadrant 3 to quadrant 1. Okay. Now, I can prove that to you. I actually kind of summarized my learning from yesterday, so I learned that without having to graph, but if you're a little rusty on that, or maybe you haven't had the same amount of time that I've had to reflect on all this, you might have said, well, you know what, I want to check this. Once again, turn your calculator on, make sure it's cleared. Blue key, plus sign number 7, number 1, number 2, and then it should all be cleared, okay? So I go to my y equals, I type in 3.7, so I'm just going to move this up a bit. Oops. I'm going to just move my camera up so you can see all my keystrokes. 3.7, this is where the x is, right beside stat, x, plus 1.2. When I press graph, I should see the line clear. The graph is exactly what I thought, right? Rising to the right. So you could do that with all of these. Now with this one, if I multiplied through, right, I would get a negative 2x. Whatever number is negative 2 to 2x falls to the right. The end behavior, well, let's take a look at this one. I'm going to do a fast clear, just like this. Not really what I recommend all the time, but it kind of saves a bit of time now. Remember, your negative sign is x plus 3.7, close bracket, and then I press graph, and sure enough, it's coming down, quadrant 2 to quadrant 4. All right, so here, if you look at the ones with all the negative, dropped. Drop or fall means the same thing, and they were all quadrant 2 to quadrant 4. Right? So any graph that falls starts in 2 and ends in 4. So 2 to 4. So this one, another negative. The same rules apply, right? Slope direction is falls to the right. End behavior, quadrant 2 to quadrant 4. This would be fractional, but it would be a positive. Slope direction rises to the right. End behavior, quadrant 3 to quadrant 1. Here, don't be fooled. The leading coefficient, in proper form, the x should be written. Now, this is just a constant, but these constants are a little tricky, right? Because we had a constant here. We did have a constant yesterday, but it was negative. The leading coefficient, this is actually y equals 0x plus 5. Now, these are a little odd, right? So anything that's odd or out of the normal, I would just type in, press graph, and here's where my graph is, right? Yesterday's constant, if we just look over here, an example y equals negative, the constant was below the x-axis, so it was 3 to 4. But this constant is above the x-axis. It's because it's a positive 5, not a negative 5. Leading coefficient is 0. 0 doesn't have a sign. It's flat, right? So the slope is 0. There is no, it doesn't move up or down. The end behavior, well, it would be quadrant 2 to quadrant 1. Okay. Which of the equations are in proper form? Well, the ones in proper form would be what? Number 1, number 2, number 4, not number 5, it has brackets, not number 6, it's flipped. And I guess number 7 would also be technically in proper form. You don't have to write, so it would be proper. If A is positive, what can you conclude about the graph? The line rises to the right. If A is negative, what can you conclude about the graph? The line falls to the right. And that to the right phrase means as you read across the page, right? Like as you read a graph across the page. So as we move across the screen or across the page, what does the line do? Well, as I move from this side of the line to the other side of the line, it's rising, right? we read left to right. Okay, so that's the homework. I'll post the homework answers on the blog too. Just to get into assignment 5, it's a big deal. The assignment 5, it's hopefully going to put a lot of things in perspective. Now, I don't think, we'll see how far we get today. I'm not sure if I'm going to get through all the examples. I might leave one example for tomorrow. And it is going to be a work class tomorrow, I think. And it's an in-service Friday, so you could just work on your own on Friday at home or wherever you are. If you have time, just catch up when you can. So we're going to talk about x and y intercepts today. To determine the x and y intercepts of a linear function, that's one of our goals, to solve two special points on the graph of any function. The y-intercept is where the equation, the y-axis, and the x-intercept is where the graph crosses the x-axis. Now, almost every graph has an intercept, right? As you can see, this line crosses, even like every upward facing line has an x and y interface or intercept, and every negative line has an x and y intercept. The only line both intercepts are the constants. Agreed? So if you think about it, when we had a constant function of y equals -5, it just had a y-intercept. And if I had y equals +5, it would have a y-intercept. So constant functions only have, I'm going to put a little note here. So it says x and y intercepts are two special points in the graph of any functions, and I'm going to say only graphs of constant functions only have a y-intercept. They don't have, all right, so every other graph has an x-intercept and a y-intercept, and that's just the point that crosses the x-axis and the line that crosses the y-axis, okay? I know these were all dotted for you already, but x-intercept, x-intercept, y-intercept. If this is -1, 2, 3, 4, 5, 6, 7, 8, y-intercept -8, or sorry, x-intercept -8, y-intercept 1, 2, 3, 4, y-intercept is 4. This was a nice clean graph, easy to read. However, some of the graphs that we'll be doing in the future are not nice and clean like that and don't have nice, easily identifiable intercepts. That problem for us though, because we'll be using our graphing calculator to help us. And our graphing calculator can find x and y intercepts up to 10 decimal digits. So we're in good shape with our graphing calculator. All right, so determining x and y intercepts, we're just identifying x and y intercepts on each of the following graphs of 6. And you can see every graph should be labeled, right, with the y and the x value on it. And if it's not labeled for some reason, if there's an error and it wasn't labeled, just remember the x is the horizontal axis, y is the vertical. And the x-intercept, 1, 2, 3, x-intercept of 3, right? Next one. This is one of those constant functions, right? So 1, 2, 3, y-intercept of 3, and it has no x-intercept. That's the only type of graph that won't have an x-intercept. Every other graph, if it slopes up or down, sometimes your graphing automatically show you the y-intercept when you press trace. That's what happened yesterday when we were pressing trace. At other times, you may need to enter the x value of 0, press trace, press the 0. I'll show you how to do that in a moment. Finding the x-intercept is more work. Okay, to find the x-intercept, we must find the point of intersection between the given equation and the x-axis. So I'm going to backtrack a little bit, okay? I'm going to back up, if you will just indulge me for a moment. I'm going to back up, and let's back up to yesterday's assignment, okay? So let's back up here. Y equals 3.7x plus 1.2. Maybe, oh, sorry, I don't want to confuse you. I'm going to flip over for one more sec. When we have our definitions of our x and y intercept, because the y-intercept is the line that crosses the y-axis, it occurs where y equal, or where x has a value of 0. So the coordinate point is, remember coordinate points have an x and a y value? So any intercept will have one of the coordinates as 0. And you can clearly see that this point would be the point 0, 4. The y-intercept is 4. The coordinate point is 0, 4. For this coordinate point, the coordinate point would be -8, 0. Right? So the coordinate point is -8, 0. So every intercept will have one of the variables being 0. Okay, you can see this point would be the point 0, 6. This point would be the point 3, 0. Okay, so maybe what I'm going to do is I want to give you a little definition here. Okay, so definitions is the point where the x value is 0. The x-intercept is the point where the y value is 0. Okay, so I just want you to sink that in. That's what an intercept is. For an intercept, an x or y intercept, one of the values will be equal to 0. So when you're looking for the y-intercept, when you're looking for the y-intercept value, you know the x will be 0. If they ask you what the x-intercept is, you already know that the y value is 0. So if I backtrack for a moment here, I just want to backtrack to an easier question. Let's go back to what do I want to do here? Sorry, should have thought this through a bit more. Let's go back to the very beginning. Remember when we had this 2x minus 3 graph? Okay, I'm back on page 19. So if you just look on page 19, way back at the beginning, guys, page 19. Okay, and we're going to type in y, if there's anything in, and you're going to type in 2x minus 3. You're going to press graph. Now, I want to know what the y-intercept is, right? When we press, that might not happen all the time. So I'm going to show you the foolproof way to get the y-intercept really easy. We just use our second trace. And remember what happened when we pressed value? We got to put whatever we want in for x. So I know that to find a y-intercept, I'm going to put 0 in for x, press enter, and I get y equals -3. Okay, so the reason I went back to page 19 is this is my y-intercept, and the calculator has easily shown that to me. Y-intercept equals 3. Okay. Now, the other thing that I have to show you that I'll go into in a moment, except we know that when we used our second trace, that first option value lets us put any value we want in for x. So I know if I put 0 in for x, it's automatically going to give me my y-intercept. Okay? So that's a really easy way to find your y-intercept. It's the x-intercept that's tricky. So if you just follow along with me again, sorry about this. So I'm on page 25, okay? And notice something else about that y-intercept. Y-intercept is -3, and that's what the b value equals. So as long as your equation's in proper form, the b value gives you the -3. All right, so let's try this. Other times you may need to enter the x value of 0, press trace, and press enter. This always works because the y-intercept always has a value. So press second trace. This always works because the y-intercept has a value of 0. Okay, so I'm going to say to find the y-intercept, 0, and then press enter again. And that will give you your y-intercept. Okay, to find the x-intercept is more work. To find the x-intercept, we must find the point of intersection between the given equation and the x-axis. So we're going to do this slightly different. So what we're going to do is, in order to find the x-intercept, and it's tricky, but for this equation, I want to find this value here, right? So there is no shortcut to use to find like we used for the y-intercept. The y-intercept's really easy, right? We just enter, I can follow these steps. So let's just enter this equation into your calculator. Y equals 2.32x subtract 7.51, okay? So when I press graph, I'm going to see the same graph that my calculator showed me, okay? So if I want to find, now that you know the little trick that this is the y-intercept, let's just check that with our calculator. Let's go second trace, like I did up here. Press value, put a 0 in, enter, and sure enough, I get -7.51, right? That matches. Okay, that was easy. I probably didn't even need to do that because it was just right in the face here. But now let's find the x-intercept. So the y-intercept is really nice and easy to find. Y-intercept is -7.51. The x-intercept, though, there's no quick using the 0 button, but it takes a little work to get there. So what I'm going to do is, the only way that we're going to do on the calculator is we've got our line that we use the graphing calculator to sketch in, and we've got the x-axis, right? Because we're talking about the x-intercept, the x-axis is really important. So this is the first line we entered in, right? This is my y1 line. y1 equals 2.32x minus 7.51. What I'm going to do is I'm going to enter a second equation into the calculator. And I'm going to enter a constant equation, and we just learned about constant equations. So I'm going to, if you remember in your y equals screen, I can enter up to 7 equations in. To find the x-intercept, we have to enter 2 equations in. So the second one I'm going to enter in is my y2. So y2 equals, well, this constant equation, the value of y, remember what this constant equation that runs right through the value of 0 would just be entered in as y2 equals 0, okay? So it's the constant equation running right through, like the x-axis, that would be where y is 0, right? So what I'm doing is kind of a backdoor, really tricky way to find the x-intercept. I want to find the intersection of these 2 lines, right? So sorry, when I showed you before, we're going to go back to our, okay, I'm going to clear everything up. When I go to my y equals screen, y1 equals this. I'm going to put in my second value, y2 equals 0. Then I'm going to go to my second trace menu, okay? And actually, we're going to choose option number 5. It says intersect, right? And that's exactly what I'm looking for. I'm looking for the intersection point of these two lines. Press enter. Okay, now it's going to ask me a series of questions. It's sitting on the y-intercept. We've already done the y-intercept. So use your back and forth, your left and right arrows to move up to the intersection point you're interested in. Okay, this is the intersection point you're interested in. Now it's asking you, the calculator will ask you questions and you have to respond to it. It's like it's a very smart little computer, right? When you tell them that you want to find an intersection points only occur if you have two lines. They're asking you if this is your first curve. They refer to all graphs as curves. This is a straight curve. So look up at the top of your screen. Is that your Y1 statement? Yes, that's what Y1, right? That's what they're calling the first curve, Y1. So in order to do calculator language speak, you're just going to press yes. Enter means yes. I'm just going to move this up so you can see what I'm doing here. Do you want the calculator to take a guess at the intersection point? You're going to say yes. Just make sure the cursor is where you want the intersection point to be. You enter yes. Okay, all questions are over. It's telling you those 0, 6, 9 and y equals 0. As soon as you see that they give you a point where y is 0, you know that's your x-intercept. Okay, so the y-intercept is negative 7.51. We found that already. And now we just found this out. The 4. Okay, y-intercept found, that was really easy. X-intercept found a little more difficult. Okay, so once again, to summarize, the y-intercept is super easy. Just go into second trace and enter a value of 0. The x-intercept's a little harder to find. We have to enter a second equation in and use our intercept button on the second trace menu. Okay, let's see if we agree with that. So these give you all the steps that I just did verbally. Okay, so you'll want to refer to these steps, but let's just read them. Press y equals, enter y2, press graph, press second, choose option 5 intersect, and then they go on to the next page, right? I'm just going to label this X intercept. Okay, so we flip over and they keep going. Press enter. Press to the question. There's 3 questions, right? Is that your first curve? Your second, take a guess. Press enter again. And as soon as you get this statement, right, you know that when you get the y equals 0, you know that's your x-intercept. Okay, I know that was a lot to absorb, so you will for sure get time to practice on it tomorrow. Maybe I think I'm going to leave example 3 for tomorrow, and you could work on example 3 on your own tonight. But let's try these 2. Okay, find the x and y intercepts. Remember what I said. If your graph is in proper form, and it is y equals ax plus b, this is going to be your y-intercept. I already know my y-intercept equals 0, but we're actually going to go through the motions. Okay, we're actually going to do this together. So take your calculator and clear everything out. Blue button, plus sign. So we're going to enter equation and we're going to find the y-intercept, because that's the easy one, right? Just to prove that it's this. Enter equation in, right? Enter equation. Into calculator. Okay, so I press y equals, and I enter it in, negative 5.2 x plus 0.87. I'm going to take a look at this graph, and it's sloping down, which makes sense because the leading coefficient is negative. Okay, Now, to find the y-intercept, right, we're going to press second trace, and then I'm going to choose option 1, value. And as soon as I just press enter, it's going to ask me what I want x to be. Well, I want x to be 0, right? And then I put a 0 in, I press enter. And then y-intercept will be 0.87. Right? So if it's in proper form, you can just pull the y-intercept out of here. If I ever ask you to show your steps, this is what I'm looking for. Okay, so one part done. Let's try the x-intercept though. That's a little harder. My y1 there. Remember, you need 2 equations in order to find an intersection point. I put a 0 in because now I'm doing the flip, right? I want the calculator to tell me the value of x when y is 0. So enter. y2 equals 0, okay? Then I'm going to use second trace again. Okay, so I'm going to go second trace, and I'm going to choose option 5. Number 5, intersect. Okay, and the only number 5. Near the x-intercept. If needed. Far away, but here I think it's pretty close already. So, yeah, enter. Take a guess. Yes. So my intersection point is when y is 0, and you'll know when you're done because it'll say intersection. Okay, I'm going to do this last part B of example 2, and then I'm going to let you try example 3 for homework. All right, so I'm clearing my calculator out. Second 7, enter. There we go. Okay. So I'm going to enter in my y equals statement. 3.45x plus 7.5. Okay, and I should get an increasing line. Sure enough, I'm going to find y-intercept. Second calc value, x equals 0. Press enter. Y-intercept is 7.5, and that matches the equation. And now I'm going to find my x-intercept. First, I have to go to the y equals menu and enter a second equation in, y equals 0. Now I go to my second trace, and I pick the intersection function. Okay, now my cursor is way up by my y-intercept. I don't want that. I want to move it right down. Okay. Is this my first curve? This should be my y1 statement, and it is, right? If you're ever in doubt, just hit your y equals screen, right? That's your y1, that's your y2. Okay, I'm going to have to start over. Second trace number 5. Okay, so there's my cursor. Is that your y1 statement? Yep. Is this your y2 statement? Yep. Take a guess? Yes. Okay, so when y is 0, this is my x-intercept. Negative 2.17. So you can see I didn't show all my work this time because it's right on the page. But if you're asked to show your work, you have to show some of those steps, right? That you have to show, you have to write out what I was showing here, okay? So it's certainly a lot to absorb. Tomorrow, I think I'll just quickly do example 3, or maybe I'll even show you example 3. And then I'll just open it up to a Google Meet, and you can have a work class because I know you might have questions for me. Okay, so that's it for today. I don't see anyone chiming in on live chat. So I guess there are no questions for today. I will maybe communicate later with email if you have any questions then. And if not, I will hopefully see you tomorrow.